8 numerical value questions have been asked from the section Binomial Theorem in the January 2024 session of Joint Entrance Examination Main Mathematics. We have already discussed the first 4 numeric value questions, and we will now discuss the question number 5 to 8 in this discussion. The examinations of the January 2024 session were held from 27th January 2024 to 1st February 2024. Now, we first take up the first question, that is in the sequence, it is the 5th question. This question has come in the JEE Main exam held on 30th January 2024 in the second shift. Let alpha is equal to sigma k is equal to 0 to n ck square by k plus 1 and beta is equal to sigma k is equal to 0 to n minus 1 of nck multiplied by nck plus 1 whole by k plus 2. If 5 alpha is equal to 6 beta, then n equals. We will now discuss the solution of the problem in detail. We are given alpha is equal to sigma, k is equal to 0 to n, nck square by k plus 1. Now what we do is sigma nck square is written as nck multiplied by nck. And we see the presence of 1 by k plus 1 here. And if we multiply by n plus 1 and divide by n plus 1, then you can write n plus 1 by k plus 1 multiplied by nck as n plus 1 ck plus 1. So multiply and divide by n plus 1. Then sigma n plus 1 by k plus 1 multiplied by nck, this is n plus 1 ck plus 1 multiplied by nck. We can also write nck as ncn minus k. ncr is equal to ncn minus r. So 1 by n plus 1 sigma k is equal to 0 to n plus 1 by ck plus 1. nck we have written as ncn minus k. So we have used this formula. That is n plus 1 by k plus 1 multiplied by nck is equal to n plus 1 ck plus 1, which is very easy. Everyone knows this result. And now, what is sigma k is equal to 0 to n plus 1 ck plus 1 multiplied by ncn minus k? And we have a result. This one is 2n plus 1 cn plus 1. 1 by n plus 1 will remain as it is. So this is sigma is equal to this one. So this is the result what we are using, that is sigma k is equal to 0 to n plus 1 ck plus 1 multiplied by ncn minus k is equal to 2n plus 1 cn plus 1. This is the result. And I was told, not many people know this result. But anyway, I will show its proof after the discussion of this question. Great. So we stop there. So go to beta. Beta is equal to sigma k is equal to 0 to n minus 1 nck into nck plus 1 by n by k plus 2. Again, we look at the ck plus 1, nck plus 1 by k plus 2, nck plus 1 by k plus 2 if I multiply and divide by n plus 1, then you will get n plus 1 by k plus 2 multiplied by n c k plus 1. Then it will be n plus 1 c k plus 2. This is same result, same result. So that will be equal to 1 by n plus 1 sigma k is equal to 0 to n minus 1 n c k multiplied by, for this we are using this. So you will get n plus 1 c k plus 2. And this one, sigma k is equal to 0 to n minus 1 n c k multiplied by n plus 1 c k plus 2 is 2n plus 1 k plus 2. So this is equal to 1 by n plus 1. And for this n c k we write n c n minus k. Then it will be n plus 1 c k plus 2 multiplied by n c n minus k. Sigma k is equal to 0 to n minus 1 is 2n plus 1 c n plus 2. 1 by n plus 1 will remain as it is. So we have used, since sigma k is equal to 0 to n minus 1 n c k plus 2 multiplied by n c n minus k, this one, is equal to 2n plus 1 cn plus 2. These are the two results I will prove after the discussion of this question. Now we continue in the next slide. We have alpha, we have beta, right? So we want 5 alpha. If 5 alpha is equal to 6 beta, then required to find the value of n. Then we can write beta by alpha will be equal to 5 by 6. So now beta by alpha is equal to, what is beta? 1 by n plus 1 into 2n plus 1 cn plus 1 by, what is alpha? 1 by n plus 1, 2n plus 1 cn plus 1. 1 by n plus 1, 1 by n plus 1 cancels. Then you will get 2n plus 1 cn plus 2 by 2n plus 1 cn plus 1. So now this is 2n plus 1 minus n plus 2 plus 1 by n plus 2. What's the result we are using? We have NCR by NCR minus 1 is equal to n minus r plus 1 by r. Here r is n plus 2, n is 2n plus 1. So this will be 2n plus 1 minus r is n plus 2 plus 1 by r, that is n plus 2. Simplify, you will get n by n plus 2. But beta by alpha is given to be 5 by 6. So because 5 alpha is equal to 6 beta will imply beta by alpha is equal to 5 by 6. That is n by n plus 2 is 5 by 6. From this you will get the result 6n is equal to 5 times n plus 2, that is 5n plus 10, that is n is equal to 10. So that is the required answer for this question. The answer for this question is 10. So that is the detailed discussion of the solution of the problem. I have told you that I will be proving those two results. That I will do in the next slide. Right. So we prove these two identities. So what are the two identities? The first identity is, prove that, first one is 2n plus 1 cn plus 1 is equal to sigma k is equal to 0 to n plus 1 ck plus 1 multiplied by n cn minus k. The second one is 2n plus 1 cn plus 2 is equal to sigma k is equal to 0 to n minus 1 multiplied by sigma n plus 1 ck plus 2 multiplied by ncn minus k. Agreed. So for this, because of the presence of this these binomial coefficients, what I will consider is 1 plus x to the power of 2n plus 1 is equal to 1 plus x to the power of n plus 1 multiplied by 1 plus x to the power of n. Yes. Yes. So if you, and how do I get 2n plus 1 cn plus 1 from 1 plus x to the power of 2n plus 1? In the binomial expansion, this is the coefficient of x to the power of n plus 1 in this. So So for this 1 plus x to the power of n plus 1, write the binomial expansion, and multiplied by 1 plus x to the power of n, write the binomial expansion. Agreed. So as I told you that we equate the coefficient of x to the power of n plus 1 on both sides. If you equate the coefficient of x to the power of n plus 1 from 1 plus x to the power of 2n plus 1, that is I will say the left hand side, and that will be equal to 2n plus 1 cn plus 1. Correct. Now how do I get the coefficient of x to the power of n plus 1? So what I will do, if I take n plus 1 c naught, this is the coefficient of 1, and we don't have x power n plus 1 in the next term. So therefore leave that. So take this next one, n plus 1 c1x. If you multiply by n cn x to the power of n, x and x to the power of n is x to the power of n plus 1. So n plus 1 c1 multiplied by n cn plus n plus 1 c2, which is x square, and a term before this is x to the power of n minus 1, that is n cn minus 1. So if you multiply, you will get n plus 1 c2 into n cn minus 1. And it goes on like that. At the end, it will come to n plus 1 cn plus 1 x to the power of n plus 1 multiplied by n c naught. It is the coefficient of 1. So if you multiply, you will get n plus 1 cn plus 1 multiplied by n c naught. Now if you see here, it is this is the subscript of n plus 1 c1, 1, 2, n plus 1. So that means if you write the sigma, k is equal to 1, so if you write this one as sigma, k is equal to 0 to n of this 1, 2, n plus 1 is written as k plus 1, yes. When k is equal to 0, it is 1, k is equal to 2, k is equal to 0, it is 1, k is equal to 1, it is 2, k is equal to n at the end, n plus 1, correct. And how this next one, n c n minus k, when k is equal to 0, n, when k is equal to 1, n minus 1, when k is equal to n, n minus n, 0. So that is the sigma notation what we have. Now these are the coefficient of x to the power of n plus 1 on both sides. Therefore they are equal. 2n plus 1 cn plus 1 is equal to sigma k is equal to 0 to n, n plus 1 ck plus 1 multiplied by n c n minus k. That is the first result. Now if you look at the second one, how do we get it? 2n plus 1 cn plus 2 will tell you equate the coefficient of x to the power of n plus 2 on both sides. So equate the coefficient of x to the power of n plus 2 on both sides. On the left hand side, it will be 2n plus 1 c n plus 2. And on the right hand side, you will get x square, the coefficient of x to the power of n plus 2. So you take a x square here, multiply by n cn x to the power of n, you will get n plus 2. And for these, there are no contributions because the next terms of x to the power of n in the second factor, it is not there. So multiply, then you will get n plus 1 c2 multiplied by n cn, a term after that n plus 1 c3 multiplied by a term before it n cn minus 1, etc. n plus 1 at the end cn plus 1 x to the power of n plus 1 multiplied by x, you will get n plus 2 x to the power of n plus 2. Therefore n plus 1 cn plus 1 multiplied by n cn1. So in the sigma notation, it will be sigma k is equal to 2 to n plus 1 n plus 1 ck, yes, multiplied by nc n plus 2 minus k. Yes, this is also true. It's also true. So the result is this one. It is an independent result, and this is the result. A 2n plus 1 cn plus 2 is equal to sigma k is equal to 2 to n plus 1 of n plus 1 ck into n c n plus 2 minus k. But look at the second identity, what you have here. In the sigma, k is equal to 0 to n minus 1. So if you decrease the k values by 2, then k is equal to 2 to n plus 1 will become k is equal to 0 to n minus 1. That's precisely what we do. So we take another dummy suffix s to be equal to k minus 2. So if that is the case, 2n plus 1 cn plus 2 is equal to sigma. So now the dummy suffix will be s. S is equal to 0 to n minus 1. Why? When k is equal to 2, s is 0. When k is equal to n plus 1, it is n plus 1 minus 2, that is n minus 1. And n plus 1, see, k is s plus 2 because k is s plus 2. And n plus 2 minus k is s plus 2. So s. So 2 cancels, you will get n minus s. And this will be sigma s is equal to 0 to n minus 1, n plus 1, c s plus 2, n minus s. So s is after all dummy, it can be replaced by k. So that is the result 2. That is the result 2. Thus, we have both the results proved, and it will be helpful if you remember these two results. I am sure that you have understood the solution of the problem and the proofs of these two identities, and they are very important, and it may be useful if you remember that. Right. We move on to the next question. That is the 6th question in the serial order. And this question has appeared in the JEE Main exam held on 31st January 2024 in the first shift. Agreed. The question is, in the expansion of 1 plus x multiplied by 1 minus x square into 1 plus 3 by x plus 3 by x square plus 1 by x cube whole to the power of 5, x not equal to 0. The sum of the coefficients of x cube and x to the power of minus 13 is equal to. So in this expansion, you have to compute the coefficients of x cube and the coefficient of x to the power of minus 13 in this expansion and sum it up. And what is the answer? That is the question. Let's now discuss the solution of the problem in detail. We are given 1 plus x into 1 minus x square into 1 plus 3 by x plus 3 by x square plus 1 by x cube all to the power of 5. This 1 by 1 minus x square, we will write it as 1 plus x into 1 minus x. And this we recognize as 1 plus 1 by x whole cube to the power of 5. So that will be 1 plus x. 1 minus x square is written as 1 minus x into 1 plus x. And this is 1 plus 1 by x whole cube whole to the power of 5. So 1 plus x, 1 plus x, 1 plus x square. And if you take the LCM here, it will be 1 plus x whole cube by x cube whole to the power of 5. And that will be 1 plus x whole square into 1 minus x into 1 plus x whole to the power of 15. 3 into 5, 15 by 15. X to the power of 15. So if you multiply, then you will get 1 minus x into 1 plus x whole to the power of 2 plus 15, 17 by x to the power of 15. So that's what we have now. We continue in the, so we will go one step further. So multiply 1 into 1 plus x to the power of 17, that is 1 plus x to the power of 17 minus x into 1 plus x to the power of 17 by x to the power of 15. We continue in the next slide. Agreed. This is what we have. And we want to now find the coefficient of x cube in the given expansion. If you want the coefficient of x cube, we find the coefficient of x to the power of 18 in the numerator by x to the power of 15. Therefore, you will get the coefficient of x cube. So, to get the coefficient of x cube in the given expansion, we take the coefficient of x to the power of 18 in the numerator of this expression. that is 1 plus x to the power of 17 minus x times 1 plus x to the power of 17. The coefficient of x to the power of 18. No, do we get x to the power of 18 in this 1 plus x to the power of 17? So if you take the binomial expansion, the highest power of x will be x to the power of 17. That's all. So there is no question of getting an x to the power of 18, that term in this one. Yeah, if you go into this one, so 1 plus x to the power of 17, the highest exponent of x is x to 17. So x to the power of 17 multiplied by x, that is x to the power of 18, and the coefficient is minus 1. So the answer is, the coefficient of x to the power of minus 18 is 0 minus 1. Right. So the answer is minus 1. So that is minus 1. Right. Now what is the coefficient of x to the power of minus 13? Minus 13 means you have to get the coefficient of x square in the numerator. The coefficient of x square in this one. Now expand this one. The coefficient of x square in sigma r equal 0 to 17 cr x to the power of r minus sigma r is equal to 0 to 17 cr x power r multiplied by x, that is x to the power of r plus 1. So if you want to get the coefficient of x square, put r is equal to 2 in the first sigma, and in the second sigma put r is equal to 1. So you will get 17c2 minus 17c1. 17c2 is 17 into 16 by 2 factorial minus 17c1 is 17. Now simplify, you will get 136 minus 17, that is 119. And what we want? We want the sum of the coefficients of x cube and x to the power of minus 13 in the given expansion. So you have to add these two, that is minus 1 plus 119, that is equal to 118. So the answer to this question is 118. I am sure that you have understood the solution of this problem. We move on to the next question. Question number 7 in the serial order, and this question has appeared in the JEE main exam held on 31st January 2024 in the second shift. Let the coefficient of x to the power of r in the expansion of x plus 3 to the power of n minus 1 plus x plus 3 to the power of n minus 2 multiplied by x plus 2 plus x plus 3 to the power of n minus 2 multiplied by x plus 2 whole square plus so on and so forth plus x plus 2 to the power of n minus 1. B alpha r. The coefficient of x to the power of r in this expansion is alpha r. And if sigma r is equal to 0 to n, alpha r is equal to beta power n minus gamma power n, where beta gamma are natural numbers, then the value of beta square plus gamma square equals. So we are given this expansion. In that expansion, the coefficient of x to the power of r is given to be alpha r, and if sigma r is equal to 0 to n, alpha r is beta power n minus gamma power n, where beta gamma are n, then required to find the value of beta square plus gamma square. Agreed. Let's now discuss the solution of the problem in detail. We are given alpha r is the coefficient of x to the power of r in the expansion of that big expansion, what we have written here. Now, first of all, let us see, if we expand this one, the highest power of x is n minus 1, x to the power of n minus 1. In this, x to the power of n minus 1, because x into this. In this n minus 1, at the n minus 1. That means the highest exponent of x in this expansion is n minus 1. But we want sigma r is equal to 0 to n alpha r. Up to n you have to go. So what is the coefficient of x to the power of n in this? There is no coefficient. Therefore it's 0, 0, 0. So in this expansion, so that will be equal, that is, this expansion is equal to sigma r is equal to 0 to n minus 1 alpha r x power r. Right? Why up to n minus 1? Why not n? The highest exponent of x in this expansion is n minus 1 only. That is why we have written like that. But we have already seen there is no term containing x to the power of n. Therefore, the coefficient of x to the power of n is 0. So even if you write sigma r is equal to 0 to n also, no problem, because alpha n is 0. Anyway, we have written this way. Put x is equal to 1. Why? We want sigma r is equal to 0 to n. So if you put x is equal to 1, you will get sigma r is equal to 0 to n minus 1 alpha r. That is this one. And this as if you put x is equal to 1, it is 1 plus 3, 4 to the power of n minus 1, 4 to the power of n minus 2 into 3. 1 plus 2 is 3. So 4 to the power of n minus 1 into 3 square. At the end, 1 plus 2, 3 to the power of n minus 1 is equal to this one. So what is this? This is sigma r equal to 0 to n minus 1 alpha r is equal to, take 4 to the power of n minus 1 common. Then you will get 1 plus 3 by 4 plus 3 by 4 whole square plus 3 by 4 to the power of n minus 1. So it's a geometric progression with first term 1 and common ratio 3 by 4, which is less than 1, and the number of the terms is n. So that will be 4 to the power of n minus 1 into a into 1 minus r to the power of n by 1 minus r. R is 3 by 4. So we get this one. So simplify, you will get 4 to the power of n into 4 to the power of n minus 3 power n by 4 power n. Yeah. Yes. This 4 will come here. 4 power n. Correct. So 4 power n cancels. 4 power n minus 3 power n. Now notice that alpha n, the coefficient of x to the power of n in the expansion is 0. This I have already explained to you. So therefore, in this sigma r is equal to 0 to n minus 1, I can write sigma r is equal to 0 to n alpha r. The sum is this only because alpha n is 0. So sigma r is equal to 0 to n alpha r is equal to 4 to the power of n minus 3 power n. That is equal to beta power n minus gamma power n, where beta and gamma are natural numbers. Therefore, beta must be equal to 4 and gamma is equal to 3. And required to find the value of beta square plus gamma square. So 4 square plus 3 square, that is equal to 25. Therefore, the answer to this question is 25. And I am sure that you have understood the solution of this problem. And we move on to the next question. That is the 8th one, the last one. And this question has appeared in the JEE Main Examination held on 1st February 2024 in the first session. The given question is, if the coefficient of x to the power of 30 in the expansion of 1 plus 1 by x to the power of 6 into 1 plus x square whole to the power of 7, 1 minus x cube to the power of 8, x not equal to 0 is alpha, then mod alpha is equal to. You have to find out the coefficient of x to the power of 30 in this expansion, and that coefficient of x to the power of 30 is given to be alpha, required to find the value of mod alpha. Let's now discuss the solution of the problem in detail. Right, we take what is given here. So take the LCM, 1 plus x to the power of 6 by x to the power of 6, 1 plus x square multiplied by to the power of 7, into 1 minus x cube to the power of 8. Agreed. Now, the coefficient of x to the power of 30, if you want, because of the presence of x to the power of 6 in the denominator, we consider the coefficient of x to the power of 36 in this one. That is 1 plus x to the power of 6 into 1 plus x square to the power of 7 into 1 minus x cube to the power of 8. X to the power of 30. Right. If you want x to the power of 30, we consider the coefficient of x to the power of 36 in the numerator. Right. And the general term of this one, The general term of this term, this one is given by 6 CR multiplied by x to the power of r, right? Here 1 plus x squared to the power of 7 CS multiplied by x to the power of 2s. Yes, another dummy suffix we have used. And here 1 minus x cube whole cube is 8 CT multiplied by minus 1 to the power of t because of minus x cube into x cube to the power of t, that is x to the power of 3t. Agreed. And that will be equal to minus 1 to the power of t into 6 CR multiplied by 7 CS multiplied by 8 CT multiplied by x to the power of r plus 2s plus 3t, where r takes the values 0 to 6, s takes the values 0 to 7, t takes the values 0 to 8. Agreed. Agreed. So to obtain the coefficient of x to the power of 36, we have to consider r plus 2s plus 3t is equal to 36, where rst is to be coming like this. That is 0 less than or equal to r less than or equal to 6, 0 less than or equal to s less than or equal to 7, 0 less than or equal to t less than or equal to 8. For such rst, r plus 2s plus 3t is equal to 36. In every case, the coefficients are to be computed and add. Then you will get the answer. So we observe. Now in this we make an observation. Suppose you take t less than or equal to 5. If you take t less than or equal to 5, it is 15. And 36 minus 15 is 21. R plus 2s will be greater than or equal to 21. R plus 2s is greater than or equal to 21. And this is not true for any r and s in their limits. So r takes values 0 to 6 inclusion, s 0 to 7. And we do not find any r and s in this limits. R plus 2s is greater than or equal to 21. No, we don't get it. We don't get it. So the highest s it can take is 2 sevens are 40. The highest r that it can take is 6. So 20 plus 20, that is 2 into 7, 14 plus 6, 20 only. So it cannot catch up 21. So you need not consider the values t less than or equal to 5. So you have to consider the values t greater than 5. That is t is equal to 6, 7, 8. We continue. We consider t is equal to 6, 7, 8. We continue in the next slide. Right. So to obtain the coefficient of x to the power 36, put r plus 2s plus 3t is 36 and consider t is equal to 6, 7, 8. Right. Case 1. Let t is equal to 6. If you put t is equal to 6, 6 3s are 18. 36 minus 18, 18. R plus 2s is equal to 18. Now start with the highest value of s. S is equal to 7. If I take, then R will be 4. Correct. Then RST will be, R is 4, 7, 6. Correct. Therefore, and now take the next value of s. S is 6. S is equal to 6. If s is equal to 6, 6 2s are 12. 18 minus 12, r is equal to 6. Correct. RST will be 6, 6, 6. Agreed. Agreed. Now we are not going further. S is equal to 6. Suppose I take s is equal to 5. What happens? If I take s is equal to 5, 5 2s are 10. 18 minus 10, 8. R is 8. It cannot take because r takes maximum value 6. Therefore, you have to stop. The corresponding coefficient is is minus 1 to the power of t, that is minus 1 to the power of 6 is plus 1 only. 6 C4, 7 C7, 8 CT. Yeah, 6, 4, T. 6, 6, 6. So these are the things. Now make the computation, multiply, you will get 616. Agreed. Now we go for the next case, t is equal to 7. Then you will get 7 3s are 21. 36 minus 21 is 15. R plus 2s is 15. Take the highest value of s. S is equal to 7. If you take s is equal to 7, R is 1. RST will be 177. Now s is equal to 6. Then R will be 3. 3, 6, 7. Now s is equal to 5. R is equal to 5. So it will be 5, 5, 7. So now the next is, now we stop there. Why? The next value of s is 4. We take s is equal to 4. 4 3s are 12. 36 minus 12, 24. R plus 2s is 24. The highest value for s is 7. 2 7s are 14. And the highest value for R is 6. That is, it amounts to only 20. Whereas it is 24 coming. Therefore, you don't get any contributions. So the corresponding coefficients are, these coefficients you have to compute. So RST 177. This is 17. And you see 8C7 is common. In all these things, the 7 is common. 8 is C7. So you get 6C1, 7C7, 6C3, 7C6, 6C5, 7C5. So when you multiply, you will get minus 2176. Is there any other case? Yes, there is a third case. So we move to the next slide. Right. We consider these. Case 3. Case 3 is t is equal to 8. If t is equal to 8, 8 3s are 24. 36 minus 24, it is 12. R plus 2s is equal to 12. Now take, now suppose I take the s value, 7, the highest value. 7 2s are 14. 12 minus 14 minus 2. So R cannot be negative. So s is equal to 6 we take. If s is equal to 6, R is 0. Then RST will be 0, 6, 8. S is equal to 5. 5 2s are 10. It is 2. R is equal to 2. RST is 2, 5, 8. And S is equal to 4. R is equal to 4. RST is 4, 4, 8. S is equal to 3. R is equal to 6. It is 6, 3, 8. Now can we go further? Suppose S is equal to 2. Suppose S is equal to 2. If you put 2 2s are 4. 12 minus 4 is 8. R takes only up to 6. Therefore it cannot. Therefore you have to stop there. So now the corresponding coefficients are this one. So write for 068, 258, 448, 638. The corresponding coefficients are this. 888 is there. Therefore minus 1 to the power of 8 into 8. C8 is common. And then write C6, 0, 6, 2, 5, 4, 4, 6, 3. So computations you have to do. You will get 882. And we recall what are the values we got. Case 1, 616. Case 2, minus 2176. Case 3, 882. So therefore, the coefficient of x to the power of 36 is coming out to be 616 minus 2176 plus 882, that is minus 678. So therefore, the coefficient of x to the power of 30 in the given expansion is minus 678. This is the coefficient of x to the power of 30. The coefficient of x to the power of 30, not 36. So this is minus 678. That is alpha. It is given. We want mod alpha. That is mod of minus 678. That is equal to 678. So the answer to this question is 678. So that is the discussion of the solutions of the 4 numeric value questions from the section Binomial Theorem that have appeared in the January 2024 session of JEE Main Examination. I am sure that you have understood the solution of all the 4 questions that I talked about in this discussion, and the 2 identities that I have derived. Please do remember those 2 identities. They are very important, and I wish you all the best. Thank you.